Hello everyone, welcome to this amazing channel of Infinity Learn by Sri Chaitanya for your LTC MPL chemistry paper discussion. And I'll be your host and host AV. So guys, let's start the session and see what were the question that you have attempted in this chapter. So the first question that you have seen is, which one of the following species is aromatic? So for any species to be aromatic, the first thing that is required, it has to be a cyclic compound, and all are cyclic compounds, so we cannot eliminate any option. Second, it has to be planar. Planar means all atom in the cyclic should be sp2 hybridized. In this thing I can easily eliminate option number 2 because this is sp3 hybridized, so this is out of scope. Then the third one has to be a conjugated. Okay, so this is conjugated, this is conjugated, this is conjugated, so all three options are conjugated. Fourth one, follows Huckel's rule. What is Huckel's rule? It should have 4n plus 2 pi electron. Okay, so that is 2, 6, 10, 14 and so on. Okay, it has 4 pi electron, right? So this should not be your answer. It has again 4 pi electron. Again, this should not be your answer. It has 2, 4, 6 electrons. So hence option number 4 is the right answer for you for this option. Sorry, for this question 1, option number 4 is the right answer. Then the non-planar species among the following. If you remember it, it's fine. If not, please try to remember that this is called cyclooctatetradiene molecule and it is non-planar. Although it has 8 electrons, so basically it has to be anti-aromatic, but anti-aromatic compounds are highly unstable, so it undergoes puckering of ring. Okay, it undergoes puckering of ring and gets a tub shape structure. Okay, so option number 1 is the right answer, whereas second and third, they both are what? Aromatic, and this is anti-aromatic. Okay, so the right answer over here is option number 1. So option number 1 is the right answer for question number 2. Talking about question number 3, anti-aromatic species among the following is. For anti-aromatic, it has to be cyclic, planar, conjugated, plus it should have 4n electrons. That is 4n electron, that is 0, 4, or basically it should not be 0, 4, 8, then 12, 16, so on. So it has 6 electron, so it is aromatic, not the right answer. It has 4 electron, but see, this is not completely planar, it is sp3 hybridized, so it is non-aromatic, so not the right answer. 2 electron, not the right answer. This is the right answer, or rather you should remember this thing, cyclobutadiene is anti-aromatic in nature. So question number 3, right answer is option number 4. Ka value is highest. Okay, so we know that Ka value is directly proportional to acidic strength. So more the acidic strength, more is the Ka value. And electron withdrawing group, that is also directly proportional to what? Presence of electron withdrawing group, because electron withdrawing group increases the acidic strength. Okay, so fluorine is electron withdrawing, nitro is electron withdrawing, electron withdrawing, electron withdrawing. But out of all this thing, this is the strongest electron withdrawing group, and hence the right option will be 2. So question number 4, right option is 2. Question number 5, talk about the carboxylic acid with least acidic strength. Least acidic strength among the following is. Least acidic strength means what? There has to be an electron donating group so that the acidic strength decreases. Okay, so 2 methyl group, hydrogen, 3 methyl group, methyl. So out of all 4, it has 3 methyl group, that means 3 donating group, and hence the acidic strength decreases drastically. So question number 5, right option will be 3rd. Okay. 6, the most acidic substance among the following. Most acidic substance, that means what? Electron withdrawing group, presence of electron withdrawing group. So more the electron withdrawing, or the strong the electron withdrawing group is, more is the acidic strength. Electron donating group, electron withdrawing group, donating, withdrawing. Triple bond is more electron negative than double bond, and hence it is the strongest electron withdrawing group. So question number 6, right answer is option number 2. Okay, talking about 7, the most polar OH bond is present in. Most polar OH bond is also meaning the most acidic alcohol. most acidic alcohol, and you know the order. The order for most acidic alcohol is methanol, then comes 1 degree alcohol, then comes 2 degree alcohol, and then comes 3 degree alcohol, and hence the right answer is option number 1. Okay. Question number 8. pKa value, this is pKa, something like this. Okay, pKa value will be least. Okay, we know that pKa value is, okay, pKa value is inversely proportional to acidic strength. That means lesser the pKa value, more is the acidic strength, right? Clear? So H2O, phenol, alkyne and alcohol. Out of all these things, we know that phenol is most acidic because the order goes in this way. The first one is sulfonic acid, which is highly acidic. Then comes carboxylic acid. Then comes carbonic acid. Then comes phenol. Okay. Then comes methanol. Then comes water. And then comes 1 degree, 2 degree, 3 degree alcohols. Okay. So if you'll see, the most acidic is what? Phenol. Then comes water and alcohol, and the last one is alkyne. Hence, the right answer will go to option number 2. So, question number 8, option number 2 is the right answer. Sorry. Statement 1. Acetic acid is less acidic than phenol. Wrong statement. Acetate ion has less number of resonance structure as compared to phenoxide ions. That is true statement. Acetate ion only have 2 equivalent structure, whereas phenoxide ions 5. So, statement 1 is incorrect, whereas statement 2 is correct. Option 3 is the right answer. 10. The correct decreasing order of acidic strength of the above organic compounds. Okay. So we should identify, we know that electron withdrawing group, okay, will increase the acidic strength. Then comes the midpoint. Okay, then comes the midpoint, and then comes the electron donating group. So this is the strong acid, and this will be the weak acid. Okay, and what is required is decreasing order of acidic strength. So this NO2 is electron withdrawing group. Okay, then it is electron donating group. Again it is electron donating group, and this is the midpoint. So first will be B. So let us see where are B. First and third option. So this is gone, this is gone. After B, that is after electron withdrawing group, should come midpoint. So midpoint is 8. So BA. Third is the right answer, whereas I can discard the first one. So 10th, option number 3 is the right answer. 11. pKa is highest for metanitrophenol, orthonitrophenol, paranitrophenol and picric acid. Highest means low, okay, or weak acid they are talking about. Okay, pKa is highest because we know that pKa is inversely proportional to acidic strength. So higher the pKa value, lesser is the acidic strength. That means they are talking about weak acid. Picric acid is the strongest acid. After picric acid, the strongest acid is paranitrophenol. After that, it is orthonitrophenol. After that comes the metanitrophenol, and hence the right answer over here. Okay, and hence the right answer over here will be option number 1. Is that thing clear? Sure. So for 11th, option number 1 is the right answer. Okay, now coming upon to the next question. 12th, for which of the following aromatic species the value of N equal to 2 in Huckel's rule? So 4N plus 2 equal to pi electron. If N value is 2, so 4 to the 8 plus 2, that means pi electron should be 10. Okay, and 10 pi electron is found in what? Naphthalene. Phenanthracene and anthracene. Okay, phenanthracene and anthracene total, if I am not mistaken, has 7 pi bond, that means 14 electron. Benzene has 3 pi bonds, that means 6 electron. Naphthalene has 5 pi bonds, that means 10 pi electron. So hence option number 1 is the right answer. Okay. 13. 128 gram of rhombic sulfur when burned in excess of oxygen liberated Q kilojoules of heat. Enthalpy of combustion of rhombic sulfur. So rhombic sulfur, if I am not mistaken, rhombic sulfur is S8, and we are doing complete combustion. So oxygen, it will give you SO2. So this is 8 and this is 8 balance. So 128 grams gives you Q kilojoules. Okay, so 32 into 8 times, 32 into 8 times is around 256 grams. Molecular weight will give you what? X kilojoules. So what is X is equal to? X is equal to 256 times Q whole divided by 128. This is the twice of Q, and hence answer has to be what? Answer has to be what? Minus 2 kilojoules, because it liberates, right? Liberate means what? Delta H is negative. Delta H is negative, so this is minus Q. So you can take it minus. Clear? So answer has to be option number 2. So question number 14 talks about enthalpy of combustion in kilojoule per mole of graphite, hydrogen and ethyl alcohol is this respectively. Enthalpy of formation of ethyl alcohol will be. So enthalpy of formation of ethyl alcohol. What is ethyl alcohol? It is C2H5OH. So with this thing, can I see I require 2 carbon plus 5 plus 1 is 6, that is 3 hydrogen plus half oxygen will give you this, and delta H is question mark over here. Okay, to get this data, what they have given is graphite, hydrogen and ethyl alcohol combustion. So carbon as a graphite combines with oxygen, okay, to give you CO2, and delta H value over here is minus Y. Then hydrogen, so 1 mole of hydrogen reacts with half mole of oxygen, okay, to give you what? H2O, because enthalpy of combustion over here is minus X. And ethanol, that is C2H5OH, reacts with oxygen to give you CO2 plus H2O. Right? To balance it, I require 2 carbon over here. There are 6 hydrogen, so I required 3. That total 2 to the 4 and 7 oxygen. Out of 7 oxygen, 1 oxygen over here. That means thrice oxygen. Right? And the delta H value over here is minus Z. First thing that we require is carbon on reactant side. We have carbon on reactant side. Hydrogen on the reactant side. We have hydrogen on reactant side. We have oxygen on left hand side. Oxygen on left hand side. What we require is C2H5OH on the right hand side. So we need to reverse this equation. So if I reverse this equation, I'll get 2CO2 plus 3H2O gives you C2H5OH plus 3 oxygen, and delta H will become positive. Then to get 2 carbon, multiply by 2, multiply by 2, multiply by 2, multiply by 2. To get 3 hydrogen, 3, 3, 3, 3. Okay. Now we need to add equation 1, equation 2 and equation 3. So if I add this equation, this CO2 and this CO2 will get cancelled out. 3H2O, 3H2O gets cancelled out. Yes or no? Right? And then 3 oxygen. So we have 2 plus 3 by 2 minus 3 oxygen. So 2 to the 4, 4 plus 3 is 7 by 2. 7 by 2 minus 8, that is 2 3 that's 6, and 7 minus 6 is 1, that is equal to half oxygen is left. That means we have 2 carbon. That means we have 2 carbon over here, 3 hydrogen over here, plus half oxygen. That will give it to you what? C2H5OH. And the delta H value will be minus 2x. Delta H value will be minus 2x. Then, sorry, minus 2y, not 2x. This is minus 2y. So, minus 2y, minus 3x plus z. So, minus 2y, minus 3x plus z. So, option 2 will be the right answer for question number 15. Okay, clear? So, option 2 is the right answer. 15. From the following data, calculate the enthalpy of formation of carbon monoxide. Enthalpy of formation of carbon monoxide. So, we have this equation. Delta H is positive over here. So, that means, can I say, in this equation, plus Y kilojoule. So, can I say that delta H is equal to minus Y kilojoule? And this is equation 1. And for delta H2, we can say it is minus X kilojoule. First thing that we have to do is we have to reverse it. That means delta H will become positive and divide by 2. So can I say that the new delta H3 will be X by 2. And for this thing, the equation will be CO2 gives carbon monoxide plus oxygen gas. Now what I want to do is I need to add delta H3. Okay, I need to add delta H3 plus delta H1. Okay, if I add delta H3, that is x by 2, and delta H1, that is minus y, what I'll get is C. CO2 and CO2 will get cancelled. Hence, carbon solid will give you the carbon monoxide plus oxygen. Okay, clear? Sorry, not only CO2. Even let us just add the 6. So carbon plus oxygen gives you CO2, and over here CO2 gives you carbon monoxide plus oxygen. Clear? Sure. And since I have divided this thing by 2, I'll be getting half oxygen over here. Okay, so this CO2 and this CO2 can cancel, and this will be 1 carbon plus oxygen minus half oxygen gives you what? Carbon monoxide. So this is what? Half. So carbon plus half oxygen will give you carbon monoxide, and this is the desired equation, and hence this should be the final answer. So x by 2 minus y. Option number 4 is the right answer. Okay, clear? Okay, which one of the following statement about thermochemistry is incorrect? Combustion is exothermic reaction, right? But the option is wrong. Lattice enthalpy of ionic substance can be calculated by applying Hess law. Yes, right, but the question is wrong. A good fuel has high calorific value. Yes, but the statement is right, but the option is wrong. Heat of combustion is determined in bomb calorimeter. That is delta H. That is wrong. It is delta E or delta U. Delta U, or that is internal energy. Why? Because bomb calorimeter is a enclosed container, has a constant volume, and at constant volume heat is what? Internal energy. So I'll go with option number 4. Question number 16, option number 4 is the right answer. 17. Enthalpy of combustion of diamond is this. Okay, so carbon as a diamond, if it undergoes combustion, it will give you CO2, and delta H is equal to minus 395 kilojoule. And the enthalpy of graphite, so carbon as a graphite plus oxygen gives you again CO2, and delta H is minus 393 kilojoule per mole. Enthalpy change when 24 grams of graphites convert to 24 grams of diamond. So here in both the cases they are 12 grams because they all are carbon. Okay, so let us calculate for 12 gram and then we'll multiply it by 2, so it becomes 24 grams. Okay, and enthalpy change when 24 gram of graphite converts to diamond. So I need to reverse this equation. If I reverse this equation, this will become positive. Okay, if I reverse this equation, this will become positive, and the new equation will be what? And the new equation will be what? CO2 gives you what? Diamond and oxygen. Okay, clear? So if I add this thing now, if I add both the equation now, oxygen and oxygen will get cancelled, CO2 and CO2 will get cancelled, and what will be the value over here? If I add this thing, so it will be 395 minus 393, so that is 2 kilojoule. Okay, so this is for 12 grams, right? 12 grams gives 2 kilojoules, so 24 grams will give you 4 kilojoules. Okay, so answer is what? 4 kilojoules. Clear? Sure. Next, velocity of ultraviolet rays is x meter per second. Velocity of radio waves will be what? X meter per second, because they both are electromagnetic radiation, and the speed is 3 into 10 raised to 8 meter per second for all electromagnetic radiation. 19. The electronic transition in hydrogen atom involving maximum emission of energy. Okay, maximum emission of energy. Clear? So yes, more the n value. Okay, more is the difference, or more is the difference between the thing, and more will be the energy value. Okay, so here from 4 to 1 there is a difference of 3, right? 3 to 1 1 1, and 5 to 3 is 2. So according to me the answer has to be what? 3. Okay, so the maximum transition, because we know that energy for the first orbit, okay, energy for the first orbit is minus 13.3 13.6 electron volt per meter. Okay, electron volt per atom. Then the second one is minus 3.4, right? Then minus 1.51, then minus 0.85, and then minus 0.5 something. Okay, I'll request you all to please remember this value. Okay, I request you all to please remember this value. This will make your life much easy. Okay, clear? So the maximum electronic transition in hydrogen atom involving maximum energy emission will be what? From 4 to 1. Okay, clear? The ratio of a specific charge of proton to electron is, okay, of proton to electron of a specific charge, okay, and we know that it has to be about 1 is to 1836, okay, it is what 1 is to 1836. Clear? Sure. Next, energy of a photon is 4.5 electron volt per atom. The wavelength of photon is equal to, energy is given and the wavelength is given in nanometer. So first thing, energy in electron volt per atom is equal to 12,400 by lambda in Armstrong. So if you want to convert lambda into nanometer, so it will be 1240 by lambda into nanometer. Okay, clear? Sure. So can I calculate lambda nanometer equal to 12400 whole divided by electron volt per atom is how much? 4.5. 4.5, that means, okay, sorry, this is 1240. So can I say that it is 4 3s are 12 and something in the range of 300. 4 3s are 1200. Okay, something in the range of 300. This is 30, not the right answer. It is 30,000, not the right answer. 3,000, not the right answer. Yeah, it is somewhat, it was somewhat near to 300. So I'll go with option number 4. Okay, so 21, option number 4 is the right answer. 22. The work function of a metal, that means phi, is 4.2 electron volt per atom. Maximum kinetic energy of a photoelectronic, so this is the kinetic energy, is value lambda. Again we are going to use the same equation. Okay, here again we are going to use the same equation. So this is a very useful equation, guys, please make a note of it. Okay, clear? So we know that energy electron volt per atom is equal to what? 12400 by lambda in Armstrong. We also know that energy of incident is equal to the work function plus kinetic energy. What is the work function? 4.2. What is kinetic energy? 2. That is equal to 6.2 electron volt. Right? So lambda in Armstrong will be equal to 12,400 divided by 6.2. So this is 6 2s are times. Okay, almost 6 2s are 12. Almost around 2000. Okay, 6 2s are 12. Okay, so almost around what? 2000. So where is 2000? This will be the answer. 22, option number 2 is the right answer. 23, ratio of wavelengths of series limit of Balmer series to the series limit of Lyman series. So for series limits, Balmer, okay, for Balmer n1 is equal to 2, we know that, but n2 is equal to what? Infinity. For Lyman series, n1 is equal to 1 and n2 is equal to infinity. So according to Rydberg equation, we know that 1 by lambda of Balmer is equal to RH 1 by n1 square is 4, n1 square, 1 square, n1 is what? 2, 2 square is 4, minus 1 upon n2 square, n2 square, that is infinity square is what? Infinity, again infinity square, 1 by infinity square will be what? 0. So can I say that it will be what? 1 by lambda, this corresponds 1 by lambda b is equal to what? RH by 4. That means lambda of Balmer series is 4 by RH. Then 1 by Lyman series, in the same way, can I say it will be RH by 1 upon 1 square minus 0. That is equal to lambda. This correspond to lambda of Lyman series is equal to what? RH. That is 1 by RH. Sorry, it is 1 by RH. What required is the ratio. So lambda b by lambda L is equal to 4 by RH into RH by 1. So RH gets cancelled, that is 4 is to 1. So 4 is to 1 is the right answer. Question number 23, 1 is the right answer. 24. Unit of Planck constant is joule per second. Okay, and the alpha particle is the heaviest fundamental particle of an atom. Wrong. Alpha particle is not the heaviest fundamental particle, that is neutron. Neutron is the heaviest fundamental particle. Rather, alpha particle is not fundamental particle as well. It's an helium nuclei. Neutron is the fundamental particle which is heaviest. And statement 1 is unit of Planck constant joule second. It is joule second, not joule per second. So and this is also wrong. This is also wrong. Right option will be statement 1 and 2 are incorrect. Okay, clear. Identify the incorrect statement from the following. Rutherford model of an atom is against the classical mechanics. That is true. C12, C14 is an isotope. True, but not the right answer. True, but not the right answer. Isobars have same masses. This is wrong statement and hence the correct option. So 25, 3 is the right answer. The total energy of electron revolving in an orbit of hydrogen is this. The total energy of an electron, and this, if you remember, okay, I have just said to remember, the first orbit energy is minus 13.6 electron volt, the second orbit is minus 3.4 electron volt, the third one is minus 1.5 electron volt, minus 0.85, and I said you to remember all this value. So basically they are talking about which one? They are talking about third orbit. They are talking about what? Third orbit. Okay, the angular momentum of an electron revolving in the same orbit will be, and we know that angular momentum is equal to what? NH upon 2 pi, where n is equal to what? 3. So it is 3h upon 2 pi. That is equal to 3h bar. Answer is this 3h bar. Okay, or you can do this thing by z square by n square is equal to E. And E over here, E naught is base, E over here is what? The first energy, E1 energy basically, that is minus 3. So total energy is given as minus 1.51, Z square is 1, N square we don't know, and E is what? Minus 13.6. Okay, so N square will be equal to minus 13.6 by 1.51. Okay, so if you will solve this thing, you will get answer as 3. Clear? Sure. So yeah, this is the case. 26, right option is option number 3. 27, based on Bohr theory, the value of when n value increases, incorrect statement is, if n value increases, velocity of electron decreases. Incorrect statement. So this can be one of the total energy of electron keeps on increasing. Say yes, it is right. See, it keeps on increasing. So that is right, right? So this is the right statement and hence not the right option. The radial distance between the successive orbit keeps on orbit decreases. The statement is right and hence the option is wrong. Okay. The radial distance not decreases, it increases. Extremely sorry, it increases. So the radial distance increases and hence this can be one of the answer. Energy difference between successive orbit decreases. That is right. So option A and option C. A and C. So I'll go with 27, option number 4. Okay. So 27, option number 4 is the right answer. 28. For the formation of 2 moles of water in its standard state, okay, in its standard state from its constituent elements in their standard state, delta H minus delta E. Okay. So basically it is the formation of 2 moles of water. So we know that hydrogen plus oxygen gives you H2O. Okay, so 2 moles, so I have to multiply it by 2, it will give you 2 moles. Okay, so gas, and this will be what? This will be liquid. Okay, so delta Ng will be what? Product is 0, minus 3, so that is equal to minus 3. So delta H is equal to delta U plus delta Ng RT. Okay, delta U over here is delta E, so we'll take delta H is equal to delta E, that is internal energy, plus delta Ng RT. So delta H minus delta E is equal to minus 3 RT. So minus 3 RT is the right answer. 28, option number 4 is the right answer. 29, incorrect statement among the following is, Bohr is applicable to H minus ion. The first one itself is incorrect. It is applicable to H, it is applicable to one electronic species, whereas H minus has 2 electron, single electron model. So 29, the first option is 1. 30, a systems absorb 180 kilojoules, 180 joules of heat plus Q from the surrounding, does work. So work is what? Negative. Change in internal energy. Delta U is equal to what? Q plus W. So it is 1800 minus 1350. So the difference is around 450 positive. So right answer is option number 3. The right answer has to be option number 3. Change in internal energy during the process. Change in internal energy is 1800 minus 1350. Right? And does the work. System is doing work, that means negative. Yes, answer has to be C. This is not the right answer. Option number 3 is the right answer. Okay, clear? Sure. Then the correct decreasing order of work function values are, work function means what? More the ionization energy, more will be the work function, and more ionization energy is lithium, then followed by sodium, and then followed by potassium. Potassium has the least ionization energy. So option goes to option number 4. 31, option number 4 is the right answer. 32, radius of second Bohr orbit. Okay, second Bohr orbit of B plus 3 will be, and we know that radius, okay, radius is equal to what? 0. What we say, 0. Yeah, 0.529 Armstrong of radius of hydrogen, that is given as what? R naught into n square, into what? N square. So second Bohr orbit into n square by z mostly. Yes, it is n square by z. So radius is equal to what? Radius of any species is equal to what? N square by z into R naught. N square. Second orbit is what? 2 square is 4. Beryllium is what? 4. N by R naught. So R is equal to R naught. Option number 3 is the right answer. How many of the following thermodynamic properties are classified as intensive property? Mass, extensive, enthalpy, extensive, internal energy, extensive, density, intensive. So only option is D. 33 is D. Okay. 34. The correct statement among the following is, electromagnetic radiation cannot travel in vacuum. Wrong statement. Frequency of X-ray is greater than the frequency of Y-ray. Wrong option, because it is smaller. SI unit for frequency of electromagnetic radiation is Hertz. True. Right answer is 3. Okay. 35. In the calculation of wave number of an electronic transition using Rydberg equation, N1 plus N1 plus N2 is maximum for first line of Fund series, second line of bracket series, third line of Lyman series, and fourth line of Paschen series. If we'll see Fund series, okay, if we'll see, it is like Lyman, Balmer, Paschen, bracket, Fund series. So N1 itself, okay, for this thing, N1 is 1, 2, 3, 4, 5. Okay, clear? So it is 5. First line is what? From 6. First line is what? N2 will be what? 6. So 6 plus 1 is 11, and that will be the maximum value. That will be what? The maximum value. Clear? Why? Because second line means what? Second line of bracket means what? 5 and 6. So that will give you 10. This is giving you 11. Okay. Then we have Lyman series, third line. So that is 1, 2, 3, 4. So 4 plus 1 is equal to 5. Do we have any other thing? So this is 10. This is 5. Fourth line of Paschen series. So 3, 4, 5. Okay. 3, 4, 5, 6. So 6 plus 3 is 9. So the maximum value is 11, and hence 35. Option number 1 is the right answer. 36. The standard enthalpy is 0 for oxygen, that is gas, ammonia no, bromine no, calcium carbonate no. So option number 36, option number 1 is right. 37. In which of the following process enthalpy change cannot be called as enthalpy of atomization? For any metal converting from solid to gaseous, enthalpy of sublimation is equal to enthalpy of atomization. So you can call it, but that's not the right option, because we not cannot. Oxygen split into monoatomic, enthalpy of atomization, not the right answer. Solid to gas, it is sublimation. So right answer is option number 3. 37, option number 3 is the right answer. 38. Internal energy is a very important thermodynamic property. Regarding internal energy, incorrect statement is, it's an state function. True. Its absolute value cannot be, its absolute value can be determined. Rather, it has to be cannot be determined. So that is the incorrect statement. Okay. 39. Which one of the following enthalpy change can have positive or negative value? Enthalpy of formation can have positive or negative. Freezing is always exothermic. Atomization is always endothermic. Vaporization is always endothermic. So this have a very specific value, whereas enthalpy of formation can be negative and positive, or positive you can say. So option number 1 is the right answer. Okay. 39 is done. 40. At 27 degrees Celsius, the combustion of 1 mole of liquid benzene, so C6H6 liquid, combustion is O2, gives you CO2 plus H2O. So this is liquid and this is gas and this is gas. To balance it, 6, 3, 6 2s are 12, 15. So it is 15 by 2. Okay. Heat of reaction at constant pressure. So at constant pressure, what we need is delta H. So delta H, the constant volume. Okay, heat of reaction at constant volume is this. That means internal energy is given. So delta E plus delta Ng RT. What will be delta Ng over here? What will be delta Ng over here? It is 6 CO2. That means product is 6 minus 15 by 2. That is equal to 2 6 are 12. That is equal to minus 3 by 2. That is equal to minus 1.5. So delta E that is given is minus 3260 minus 1.5 into R. R is 8.314 joule. Okay, it is 8.314 joule. So that is 10 raised to minus 3 has to be added for kilojoules. Okay, into temperature is how much? 27 degrees Celsius. That is 300 Kelvin. Right. So this thing can I write this thing as minus 3 minus 3260. See, 1.5 I am just taking it as 8. So 8 into 1.5 is 12, right? Because 8 1 is 8 and half of 8 is 4. So 4 plus 8 is 12 into, can I write it as 3 into 10 raised to minus 1. So 12 3s are 36 and 36 into 10 raised to minus 1 is 3.6. So that is minus 3260 minus 3.6. So it will be, if I take lump sum as 4, so it is 3264. The answer has to be minus 3264, somewhat approximately. So 3264, it is approximately, this can be the answer. 325, not the right answer, not the right answer, not the right answer. So yes, 40, option number 1 will be the right answer. 41. From the above data, calculate the heat of formation of this. So this is negative, that means delta H is equal to Y kilojoule. We need to calculate heat of formation. For heat of formation, I have to divide this thing by 2 and reverse. Divide this thing by 2, that means Y by 2, and reverse means what? Negative. So it is negative Y by 2, and hence option number 3 is the right answer. Okay. 41. 1 mole of an ideal gas is expanded reversibly and isothermally from 2 liter to 20 liter, 500 Kelvin. Correct relationship about the process. So it is expanded isothermally and reversibly. That means delta T is equal to 0. And if change in temperature is 0, internal energy is equal to 0. And since internal energy is equal to 0, this cannot be the right answer. This cannot be right answer. There are two things. Okay. We know that for isothermal and reversible process, work done is equal to minus 2.303 nRT log of V2 by V1. So V2 is 20 by 2, that is equal to 10, and log 10 is equal to 1. If log 10 is not 0, that means this entire equation will not be 0. With delta E is equal to 0, W will be equal to what? Minus Q. Okay, W will be equal to what? Minus Q, but they are not equal to 0. Okay, is that thing clear? So the only option which is not equal to 0, okay, the only option that is not equal to 0 is option number 3. So I'll go with option number 3 as the right answer. Okay, so option number 3 is what? Right answer. So 42, option number 3. 44. We need to match the following between delta H and delta E. So delta H is equal to delta E plus delta Ng RT. So sulfur. So delta N over here, delta Ng is what? That is positive. That means if delta Ng is greater than 0, okay, if delta Ng is greater than 0, then delta H is greater than delta E. So first goes to A. That means A is 1. A is 1. and the only option where A is 1 is option number 2. So that will be the right answer. Okay. Then closed system, matter and energy can be exchanged is open system. So B is 1. So B is 1. We have two options. Neither a matter nor energy can be exchanged. C is 2. So C is 2. Option number 1 is the right answer. Okay. 1 mole of an ideal gas is expanded reversibly and isothermally from 10 liters to 100 liters at 1000 Kelvin. Work done during the process is x cal. The value of x is, okay, so work done is equal to minus 2.303 into n RT log of V2 by V1. Okay, so minus 2.303, 1 mole of a gas is 1. In calories, R is 2 calorie. Since it is in calorie, we have to multiply it by 1000 to make it kilocalorie, because X is given is what? In calories, right? Into log of, what is V2? What is V2? What is V2? It is 1000. Wait, nRT, that is V2 is 100 by 10. So this is log of 10, and log of 10 is equal to what? 1. Clear? Sure. So that is minus 2.303 into 1 into 2 into 1000. Right? Clear? So if you'll see this value, that will be equal to how much? 1000. This is this 2 is in calorie, right? R is equal to 2 in calorie, so we have to multiply it by 10 raised to minus 3 as well. Temperature is 1000. Okay, so this is 10 raised to minus 3. So this and this will get cancelled to 2, 4 points. This is minus 4.606 will be the answer. That means 45. Option number 1 is the right answer. Okay. 46. 1 mole of an ideal gas is expanded from 5 liters to 15 liters against the external pressure of this. Work done during the, and everything is in joule. So work done is equal to minus P V2 minus V1. Talking about minus P, 1. What is V2? 15. What is V1? 5. So that is minus 10 liter atmosphere. 1 liter atmosphere is equal to 101 joules. So work done is equal to minus 1010 joule. Option number 4 is the right answer. Okay. Change in enthalpy when 6 gram of nitric oxide decomposes to nitrogen and oxygen is minus 18. So first of all, decomposition of nitric oxide is equal to half nitrogen plus half oxygen. Enthalpy of formation of nitric oxide is perfect. So enthalpy of formation for this thing, if I'll take for 6 gram, right, for 6 gram NO2, the enthalpy delta H is what? Minus 18 kilojoule. Clear? But nitric oxide, nitrogen is 14 whereas it is 16. So this is how much? 30 grams. For 13 grams, for 30 grams, can I say delta H will be equal to minus 18 into 30 by 6. So this is 6 3s are 18, and this is delta H is equal to minus 90. Okay, this is decomposition, but for formation I have to reverse this thing, and if I reverse this thing it will become positive 90 kilojoules. So option number 3 is the right answer. 48. The thermodynamic property which is a path function, we know that heat and work is a path function. Heat is the right answer. Okay, so 49. Statement 1. Standard enthalpy of monoclinic sulfur is 0. Wrong statement. Rhombic sulfur is 0. A thermochemical equation must be balanced by fraction only. Wrong. It can be balanced by any number as well. So both are incorrect. 49. 50. Consider the reaction. Graphite plus oxygen gives you CO2 plus this. That means delta H is equal to minus 394 kilojoule per mole. Incorrect statement is, it's an endothermic reaction. No, it's an exothermic reaction, and this is the right option. So 51, option number 1 is the right answer. Okay, clear. So that was the all 50 question that you have attempted in your MPL chemistry, and I hope that guys I have given you a fair clarity why the options are right and why other options are wrong. For any doubts, any difficulty, please post your question in the comment section, and I'll definitely revert you on that thing as well to give you the clarity. With this thing guys, thank you so very much for joining. Thank you. God bless you all.